Physics is all about measurement and quantification. Many measurable physical quantity that we encounter in physics has only numerical value. And such measurable physical quantities are known as scalar or scalar quantities. Therefore, we can define scalar quantities as those quantities that has only magnitude. Scalar quantities are those quantities that has only magnitude. Remember, another name for magnitude is what? Numerical value or size. We have various examples of scalar quantity. Length is a scalar quantity. Talking about length, we're talking about both distance. Distance is a scalar quantity. Speed is a scalar quantity. Time is a scalar quantity. Temperature is a scalar quantity. Energy is a scalar quantity. Density. In measuring them, we consider only the numerical value. We do not consider its direction. Let's take, for instance, if we measure a length from here to here is equal to 4 cm, and we have another length from here to here is equal to 2 cm. To add the two of them, because direction is not considered, we can add the two of them by a simple arithmetic. Therefore, the total length here will simply be 4 plus 2, and that will give us what? 6 cm. If we measure the speed of a car, let's take, we have 50 kilometers per hour. 50 is the numerical value. Kilometer per hour is just each unit. Direction is not indicated here because speed is what? A scalar quantity. On the other hand, there are some physical quantities that has both magnitude and direction, and such physical quantities are known as vector quantities. Therefore, we can say that vector quantities are those quantities that has magnitude and direction. So in considering vector quantities, we take cognizance of its magnitude, that is its numerical value. We also take cognizance of its what? Direction. So vector quantities are those quantities that has magnitude and direction. We have various examples of vector quantities, like example, acceleration is a vector quantity. Velocity is a vector quantity. Force is a vector quantity. Momentum is a vector quantity. Weight is a vector quantity, etc. So these are the various examples of a vector quantity. In a vector quantity, we consider magnitude and direction. Let's assume we have 50 kilometers per hour east. If we have this value, 50 stands in as the magnitude, kilometer per hour stands in as the unit, while east indicates the direction. So in vector quantity, we consider both what? Magnitude and direction. And vector representation. Vectors are represented with arrows. Vectors are represented with arrows. If you're used to road design, you will see that after constructing a road, in designing the road, an arrow is being drawn from one point to another. It is because a car undergoes velocity, and a velocity is a vector quantity. So in designing the road, you use what? An arrow. So that is why we have that arrow on our road surfaces. In our next class, I will be teaching you on how to add these quantities, because for addition of scalar, we use simple arithmetic, because direction is not considered. Why for addition of vector, we use geometry arithmetics, because direction is what? Considered. Join me in my next class as we take step-by-step approach on addition of vectors. Bye!